Ever open your favorite app and bam, it's totally glitching out? Or maybe a software update that was supposed to make things better actually makes them worse.
Yeah, we've all been there.
Well, you're experiencing the fallout of software testing, or more likely, the lack of it. And today we're doing a deep dive into this surprisingly fascinating world.
It's true. It's fascinating how something so crucial can stay completely hidden until, well, something goes wrong, right?
Right.
And yet, think about it. Every time you use an app, browse a website, even drive a modern car, software testing is working behind the scenes.
It really is the silent guardian of our digital lives.
It is.
And we've got the ultimate guide here to help us unpack it all. The ISTQB Certified Tester Foundation Level Syllabus. Now, that might sound a little intimidating, but think of it this way. We're taking all that dense knowledge and distilling it down just for you.
That's right. The ISTQB, for those who don't know, sets the global standard for software testing certification.
Okay.
So rest assured, what we'll break down some of the technical stuff, the insights we're going to uncover here. They're relevant even if you've never written a single line of code in your life.
That's right.
Because we're all users.
Exactly. Okay, so Chapter 1 jumps into, like, the fundamentals of testing.
Yeah.
And I got to admit, like, reading through this, I realized I had fallen for some, like, classic misconceptions about what software testing, even IS.
Oh, yeah.
And you probably have too.
Oh, for sure.
So if you've ever thought, like, testing is just someone sitting at a computer randomly clicking around until something breaks.
Oh, if only it were that simple. That's definitely a myth. In reality, software testing, it's a very systematic process, and it's woven throughout, the entire life cycle of that software.
Right.
From, the first line of code that's written all the way to those updates that you were talking about, that sometimes make things worse.
Mm.
And it's not just about finding those pesky bugs. It's about preventing them in the first place. It's about assessing risks. And ultimately, it's about giving everyone, from the developers to the end users, confidence that the software actually does what it's supposed to do.
So it's more like building a house than I initially realized.
Yeah, exactly.
You wouldn't just, like, slap on a roof and hope for the best, right? You've got inspections at every stage. You want to be sure the foundation is solid, the wiring is safe.
Precisely. And just like those inspections, ensure you have a functional and safe house to live in, software testing does the same for, well, our digital world, right?
Yes.
Each test has a specific goal. And you know what? These goals, they can actually change depending on what's being tested, what that software is meant to do.
And that's actually where it clicked for me when I was reading the syllabus.
Yeah.
And they give this great example of, like, comparing a banking app versus, like, a mobile game.
Right.
The testing objectives for those two things would be totally different.
Oh, absolutely. I mean, think about it. For a banking app, what's paramount?
Security.
100%.
Yeah.
So you're testing how well that app safeguards your data, how it encrypts transactions, can it withstand attacks from hackers?
Right.
Now contrast that with a mobile game where user experience is king.
Okay, yeah.
Right. Is the game responsive, visually appealing? Does it run smoothly on different devices?
Yeah.
Those become your primary testing focuses.
That's such a good example because it really highlights that it's not just does it work, but does it work for its specific purpose?
Exactly.
And I feel like that's a really key takeaway for anyone listening. Like, testing is all about giving the developers, and honestly everyone involved, the information they need to make smart decisions.
Throughout the entire process.
Yes,
From
exactly.
beginning to end.
And that actually brings us to another myth that I feel like I hear all the time, this idea that, like, the goal of testing is to prove that the software is perfect.
Oh, yeah, the elusive perfect software.
But realistically...
They're trying to catch every single raindrop in a thunderstorm, isn't
Yes,
it?
exactly.
We're not after the impossible. Testing is really about minimizing risk. We can't eliminate every single defect, every single bug, but we can definitely identify and address the most critical ones.
So accepting that we can't achieve perfection actually helps us build better software.
It does.
Interesting. And, that leads us to what I find so interesting, which is, like, the why behind testing. Like, why do we even bother?
Yeah.
And I think at first glance, it seems like, okay, well, we want to catch those bugs early, save ourselves some money down the line.
Sure.
But it's so much more than that, right?
You're right. It goes way deeper than that. Section 1.2 of the syllabus, it really dives into this, and it emphasizes testing's crucial role in what's called quality control.
Okay.
You can think of it as this, like, essential safety net for the entire project.
So we're talking, like, happy users, projects being delivered on time, on budget.
Absolutely. It all ties together.
It all ties in.
It does. And speaking of, that big picture thinking, the syllabus also makes this really clear distinction between, and I know these terms get used interchangeably all the time, but there is a difference between testing and what's called quality assurance, or QA.
Right.
They're not the same thing, are they?
No, and I feel like I've always kind of used them interchangeably.
So many people do, and it's completely understandable.
Yeah.
But understanding the nuance there, the difference, is actually really key because testing is a vital part of QA.
Okay,
But QA is like the overarching system.
got it.
Think of QA as like the project manager, making sure everything is on track,
Mhm.
keeping things moving, and then testing is like this very meticulous inspector, making sure that each component is actually up to par.
Okay, so QA sets the standards, the processes for quality throughout the entire project.
That's a great way to put it, yeah.
And then testing is one of the ways that those standards are met.
You got it. And to really, drive home the importance of really robust testing, I have to share a story.
Oh, I love a good story.
Back in the 90s, the European Space Agency, they launched this satellite. Cost millions and millions.
Okay, this is going to end well, is it?
Unfortunately, no.
Yeah.
Minutes after liftoff, the satellite just veered completely off course and self-destructed.
Oh, no.
The culprit, a software bug.
Wow.
A conversion error missed during testing led to this disastrous miscalculation in the rocket's trajectory.
Talk about a costly bug.
You can say that again.
It really emphasizes how even what seem like small errors can have huge consequences.
Huge.
And honestly, I feel like it makes you really appreciate all the meticulous testing that probably goes into everything around us now.
Oh, absolutely.
I know I've definitely had my fair share of frustrating experiences with buggy software, whether it's like a crashed app or lost data or just a website that just refuses to load. I mean, it's happened to all of us.
It's all of us at some point, yeah.
Right. But like those are just minor inconveniences.
Yeah, exactly.
Imagine the implications in things like healthcare or finance transportation,
Oh, yeah.
where software glitches could like far-reaching and potentially even dangerous consequences.
Absolutely. Software is so deeply embedded in our lives now. It's everywhere. So its reliability, it's paramount. And that's why understanding these, even the basic principles behind testing, is so important, even for people who aren't, coders or programmers.
So get ready for some deep thoughts, everyone, because it's about to get a little philosophical.
A little bit, yeah.
Chapter 1 presents us with these testing principles, and some of them, I have to say, are surprisingly profound. They are. This one in the syllabus, it really made me think. It says, testing shows the presence, not the absence of defects.
Right.
Which seems like so simple on the surface.
It does, doesn't it?
But I feel like there's a hidden depth there.
Yeah, there really is. And what's fascinating about that principle is that, testing, it can only ever reveal what is there, not what isn't there. So we can find and expose defects, absolutely. We can tell you, here's a bug, here's an issue, but we can never, ever say with 100% certainty that there are NO defects hiding somewhere in that code.
So it's kind of like if you're searching for buried treasure,
Okay, yeah.
finding one gold coin doesn't mean that there aren't a bunch of others still out there.
100%. And that's why we can't ever guarantee the absence of defects.
Okay.
We can just keep searching. And that's why testing is this ongoing process.
Got it. Okay, next mind bender from the syllabus. Defects clustered together.
Oh, yeah.
How does that work?
Yeah.
It sounds like bugs are like social creatures. They just hang out in groups.
It's funny you say that because it actually connects back to that Pareto principle, that 80-20 rule that you might have heard of.
Right.
In software, we often find that 80% of the problems stem from just 20% of the causes.
Okay.
So if you can identify those, troublesome areas early on, you can address a big chunk of your potential defects right there.
Focus on the hot spots.
Exactly.
Love it. Okay. Now, this one really threw me for a loop, and it's this idea of the absence of defects fallacy.
Right.
And I'm thinking, how can there be a fallacy about something not being there?
Right. It's kind of a weird way to think about it. But it gets at a really, really important point, and that is, can a piece of software be technically perfect, completely bug-free, and still fail?
Wait.
And the answer, surprisingly, is yes.
How? It doesn't seem fair.
I know. It's like you did everything right, and
Yeah.
yet. But think about it this way. Imagine a website that's beautifully designed, it's flawlessly coded, not a single bug, but it's impossible to navigate.
Right.
It might be technically sound, it might be bug-free, but if users can't figure out how to use it,
Useless.
it's a failure in their eyes.
Totally. It's like that saying, you can lead a horse to water, but you can't make it drink.
Exactly.
It's like they built this beautiful website, but no one can use it.
Exactly. And that's a key point here. So even without those bugs, software can totally miss the mark if it doesn't consider the user's needs, how they're actually going to interact with this.
So testing needs to go beyond just the technical aspects.
100%.
It needs real-world feedback.
It does.
You need to understand how people are using this.
And that's something that, even if you're not a programmer, these testing principles, they actually have applications in everyday life because it's about thinking critically about any system or process.
That's so true.
Mm-hmm.
And it's like we were saying with the house example, right? Like, yeah, you want to make sure it's structurally sound, but you also want to make sure that it's livable.
Right. Does the floor plan make sense?
Exactly.
Can you actually open the windows?
Exactly. Now,
Okay.
moving on. Chapter 2 in the syllabus. Testing throughout the software development life cycle.
Okay.
And this is where things get, I think, really, really interesting.
Yeah.
Because, testing, it's not this one-size-fits-all thing. It actually adapts to different development approaches.
It does. It's like, if you're planning a trip, if you're going on a cross-country road trip versus a spontaneous weekend getaway, you're going to need to approach those very differently, right?
Right. You're not going to book your hotels months in advance.
Exactly.
If it's a last-minute thing.
Exactly. And it's the same with testing. So the way that we test software really depends on how we build it.
So the way we build it dictates the way we test it.
Yes, exactly. And the syllabus highlights two key approaches that are super relevant, in the industry today. And those are Agile and DevOps.
Okay.
So Agile is all about embracing change.
Okay.
Software is developed in these short bursts, with constant feedback and adjustments along the way.
So it's iterative.
It's very iterative. And because of that, testing, it becomes highly iterative as well and very collaborative.
Okay.
So we're testing continuously, making sure each piece fits as it's added.
So agile testing is like building with Legos, where you're constantly adding, adjusting, making sure everything snaps together as you go.
Ooh, I love that analogy.
Yeah.
That's perfect.
Yeah.
Now, DevOps takes us a step further.
Okay.
DevOps is all about breaking down the walls between, the development team, the people writing the code, and the operations team, the people who are actually, deploying it and maintaining it.
Okay.
The goal here is rapid releases, getting that software out there quickly, and continuous feedback.
Got it.
So picture a software pipeline, constantly flowing.
Yeah.
With testing as a crucial checkpoint at every single stage.
So it's like a river, carving its path. Just this constant stream of improvements and changes.
I love that. You're good at this.
And speaking of pipelines, the syllabus mentions this term shift left, which sounds very intriguing.
It does.
What is that?
So shift left, it's about bringing testing in much earlier in the development cycle than, maybe traditionally it has been.
Okay.
So instead of waiting for a completed system to start testing or testing individual components, sometimes even writing tests before a single line of code exists.
Wow. So it's like having an expert blueprint reviewer on hand as the architect is sketching so that you catch any potential flaws early on.
Exactly. You're catching them before they become these concrete problems that you have to go back and fix later.
Love that.
Yeah.
Okay. So now with all of this testing going on,
Right.
it seems like there's a lot to keep track of.
There is.
Which I'm sure there is.
Yeah.
But luckily, the syllabus very helpfully breaks down these different levels and types of testing.
Yes. It's like a taxonomy of bug squashing.
I love it. Okay, I'm ready. Make me a bug squashing expert. Break it down.
Okay, so imagine a pyramid.
Okay.
At the base of the pyramid, you have what's called component testing, which focuses on those individual building blocks of the software.
Okay.
As you move up that pyramid, you have integration testing, so making sure that all those components work together harmoniously.
Okay.
Then you have system testing, where we look at the entire system as a whole. And finally, at the peak of our testing pyramid, we have acceptance testing, where we make sure the software meets those user needs and is ready for the real world.
A pyramid of quality.
I love it.
I love it. But what about those different types of testing? Is that where it gets really, really granular? It's like we're taking the software and we're putting it under a microscope, right?
Yeah, exactly.
So give us the lowdown. What are these testing types all about?
Okay, so think of it this way. You have functional testing.
Right. Okay.
Functional testing is all about what the software does. Does
Okay.
it perform the actions, that it's supposed to perform?
Got it.
Then you have non-functional testing,
Okay.
and that's about how well it does it.
Okay. So,
So we're talking about, is it fast enough? Is it secure enough? Is it easy to use?
got it. Got it.
All those things that, as a user, you encounter every day.
So it's like if functional testing is making sure that the car starts and it drives,
Yes.
no non-functional is making sure it's got good mileage and safety features and a comfortable interior.
100%.
All the things that make a good car great.
Exactly. And just like you wouldn't buy a car without, considering all of those factors, right?
Right.
Successful software needs to ace both functional and non-functional tests.
I love it. Okay. So we've covered a lot of ground here. We've talked about the what, the why, kind of the how of software testing. But I think it would be a disservice if we didn't at least touch on the future. And I was so surprised to see that the syllabus actually touches on this too.
It does. Yeah. Chapter 6 kind of dives into, looking ahead a little bit. And one of the big things it highlights is this growing importance of test automation, which, I know when people hear automation, they start thinking, oh, here come the robots. They're going to take our jobs.
Right.
But it's not really about replacing human testers entirely. It's more about empowering them, making them even more effective at what they do.
So it's less about robots taking our jobs and more about giving human experts better tools to do their jobs.
Exactly. Exactly. So think about it this way. What if we can free up those human experts from, those really tedious, repetitive tasks
Yeah.
and let them really focus on those complex, creative, nuanced aspects of testing that really require that human touch.
So automation kind of takes care of the routine checkups.
Exactly.
And then the humans, they get to come in and be the software detectives, really digging into those more complex issues.
Exactly. I love it. That's a great way to put it.
This whole deep dive has given me such a new appreciation for, honestly, this unseen world that kind of just hums along quietly in the background, but it's keeping our digital lives running smoothly.
It really is. It's a hidden world, but one with, like we were talking about earlier, huge impact.
Use.
And I think as we rely on software more and more, its quality, it only becomes more critical.
Absolutely. Well, on that note, that wraps up our deep dive into this fascinating world of software testing. We hope you learned something new today.
Yes.
And hey, maybe you'll even look at those software updates in a whole new light.
Absolutely. Until next time, keep those digital minds curious. There's always something more to discover.